Okay, lovely jubbly. So this is an animal transport question, and it's got a lovely graph. We love graphs, we love them. And it's homework time again, so of course I've got a ruler and a highlighter and a pen and a pencil, and guess what? I've got a calculator as well. And I might need it. I can see there already the C word. So, but before I do anything, I need to look at my graph, because otherwise nothing makes sense. So, what's this graph showing? Volume changes in the left ventricle of a mammal during one complete cardiac cycle. Letters A, B, C, D indicate phases of the cycle. So let me look. So I've got time along here. So this is during one heartbeat, and I've got the volume, and that's of the ventricle. I'm just going to remind myself that I'm talking about the ventricle. So here on this bit, if this is my ventricle, the volume of it is increasing, and as it goes down the volume is decreasing, and there is no reason why you can't do this movement in an exam. So if my volume is increasing, what do I know? My ventricle's relaxed, so this, I'm going to just annotate it up here, relaxed and filling, and if it's decreasing, it's contracting and emptying. So that's good. So this is when it's relaxed and filling, and that's when it's, so okay. And then I'm just going to remind myself of my blood flow, so it's coming in, valve, out, valve. So when the blood's going in, the AV is open, and when it's going out, the semilunar is open and the AV is shut. So I've got that flow going through and out. Okay, so thinking of what's going on here, and I can move to part 1. Calculate. Lovely, I've got my calculator. The rate at which this heart is beating. Show my working. And it's all 3 marks, fantastic. So, first of all I need to know how long one beat is. So I'm looking for a repeating pattern, and they're really helpfully, so I could go from the start of A to the start of A, or the end of A to the end of A, or, well, I haven't got another C, so I'm going to use A, and I'm going to go, because the end is there and this one's on a whole number, I'm going to go start to start. So that is 1B. Okay, so one beat's taken from point 1 to point 8. Time for 1 beat equals 0.8 minus 0.1 seconds, which equals 0.7 seconds. And I want to know now how many times I can do that 0.7 seconds in 1 minute, because you would always do your heart rate in minutes. So 60 seconds in a minute. I want to know how many of those I can fit in. 60 shared by 0.7, 85.7. I'm thinking I can't have a 0.7 of a beat. I'm going to call that 86. I'm going to round it to 86. 86 beats per minute. And I'm not going to abbreviate that because I'm not sure that BPM is a proper thing. So if in doubt, write it in full. Name 2 systems that can change heart rate. So what do I know about heart rate? Okay, so I know about the SA node, and I know that that's attached to, you know, that's got a nervous supply from the brain. So system, nervous system. And I know that should I ever venture onto a roller coaster, I will get a big surge of adrenaline and my heart rate will go up. And adrenaline is a hormone, and hormones belong in the endocrine system. So I don't even need to run through all the systems of the body. I can just think, what makes my heart rate go up? So, let's see. Use the letters A, B, C or D. Okay, so we left me gaps there to indicate when the following happen. So, the bicuspid atrioventricular valve is open. So it needs to be open, back to my little diagram, when the blood's flowing in and the ventricle is filling. So that'll be the ventricle volume going up. So that's B. Okay, that seems to be quite straightforward. Then we've got the bicuspid closes. And I'm thinking that's quite tricky to tell off that graph. So I'm just going to, the other thing I know is it goes shut, open, yeah? So. So if in B that valve is open, something's going to shut. Then something's going to open to let things out. Then that's going to shut. So I'm going to do the easy bit first. So the next one is the aortic valve is open. Opening valves are always easier. So this is when it's contracting and emptying. So that's going to be D. Which leaves me with C and A. What's going to shut? What's going to shut when? So when the so back to my diagram. When the semilunar is open, the AV valve is shut. So it's got to shut before the blood leaves. So that's going to be a shutting. And then that only leaves me with A, and I can just put that in. Fantastic. Aortic valve. Shall I just check that? Aortic valve closes. It needs to be shut before the heart refills with blood to maintain the blood pressure. So before it relaxes to stop the backflow through into the ventricle. So that does make sense, so that's okay. Shift of focus again, part C. Describe the function of the AVN. So, just again, talking about the AVN, little heart, SAN, impulses, AVN, down to the bottom, up the sides. And I need to remember why that's important in terms of my blood coming in and leaving. It needs to leave from the bottom upwards. Okay, so AVN, the AVN, and I'm just going to use their abbreviation, receives the impulse from the atria. So remember, the SAN sends it out across the atria, gathers together into there. I don't like that word impulse actually, because it's not, I'm sure, missaid. Wave of excitation. It's not quite an impulse, it's not going through a neuron, it's going from the atrial wall, so it's got to be a wave of excitation. There is a delay to allow atrial contraction to complete. And I'm just going to put in the significance of that and ensure that ventricle contraction can't write and talk, after the atria. And then the next job is to send the wave of excitation is transmitted to the bundle of hiss, to go to the apex, so the ventricles contract from the bottom up. Now that seems like quite a lengthy answer for just 2 marks, but you don't know what's on the mark scheme, so you know, the more you put down, the more likely you are to hit the available marks.